Hello, welcome to the hands-on exercise of POS taggers, that is lexicon and rule-based POS taggers. So as I mentioned before, we will be having a in-depth hands-on on different types of POS taggers, which we studied until now. So this will be a guided exercise. In this guided exercise, we are going to explore a data set called as Wall Street Journal data set. The speciality of the data set is it is a data set consisting of different sentences, and within each sentence each word is tagged with a POS tag already. So it is a corpus, it is a large corpus which consists of which consists of words already tagged with a corresponding POS tag. So we are going to use this data set, and we are going to explore this data set, and we try to understand the different elements of the sentences and the particular types of POS tags which are available, and how it is tagged, and etc., all those things using NLTK library. And finally we are going to build a lexicon based and a rule based POS tagger using this text corpus as a training data. So I am going to divide this exercise into three following sessions. That is, the very first thing would be reading and understanding the tagged data set. Then we are going to have a exploratory data analysis. What does this term indicates? We try to have a exploration on different elements of the data set. Look, like what we are going to do, we are trying to get what kind of tags are available within the given corpus, and how many unique tags are present within the given corpus, and how each of the word are tagged with a particular tag, and why it is tagged so, and what are the tags which are coming after and before given a target word. So all those things we will be having within the exploratory data analysis. Once that is done, once we have a brief idea about the text corpus, then we will be finally building out a lexicon based POS tagger and a rule based POS tagger. At the end of the session, we will be also evaluating each of the POS tagger, and we try to compare the differentiation and how it is different, like how each of the POS tagger different from each other by evaluating certain metrics. So since we had a overview of the hands-on session, now we'll try to move with the very first step of our exercise, that is reading and understanding the tagged data set. So when we deal with the text data, so we generally try to include one of the famous library, that is NLTK library. So I'm going to import that NLTK library at the very first. So then I'm going to import other libraries such as NumPy, Pandas, and pprint time, etc., which are very much essential for the when it comes to exploratory data analysis step. Then as I mentioned, we are going to build a lexicon based and a rule based model, right? So for that, I'm going to use sklearn as a backend. So for that, I'm going to use sklearn.model selection and imported train test split. So this is very much an essential to split the data set into training and test data set. So finally, we are also importing other aspects of NLTK, that is tokenizing, etc., directly from the NLTK. So as I mentioned, we are going to explore a data set called a Wall Street Journal data set. So it is available within the NLTK, and it is available in the form of, in the name of a tree bank data set. So we'll try to download that first. So we'll try to run that now. So we have downloaded the data set. Now we will have a look on the different sentences available within the tree bank data set. So here I am going to initialize a variable called corpus, and I am going to create a list. And here what I am trying to do, from the nltk.corpus.treebank, I am going to visualize the tagged sentences. So this is how the function look like. So I have done that over here, and let's have a look of a top 3 sentences within that text corpus. So here you could clearly see that it is a large list, and the list consists of a sub list, and each of these lists represent a sentence. So the very first list represent the very first sentence, and each of this sentence you could see that consisting of different words. So you could directly read this as a sentence like Pyri Viken, 61 years old, will join the board as a non-executive director November 29th is a overall sentence. So each sentences is already split into words, and each word is already tagged with a particular POS tag. So by taking a look of the very first sentence, it will be available in the form of a list, and list of tuples. What we can see, it is a list of tuples. Each tuple represent a word and a POS tag associated with it, right? So this is how our data set will be looking like. So uh, I will be summarizing what we just saw. So in the list mentioned above, each element of a list is a sentence. So also note that each sentence ends with a full stop. So you could clearly see that the last element of each list, you could see it as a full stop, right? So that and also the POS tag associated with that full stop is a full stop again. So thus it indicates that it is a end of a sentence. So the end of a sentence is denoted by a presence of POS tag. That's what we can understand. So also we do not need the text corpus to be segmented into sentence, right? So whenever we deal with any task which we involve in building a like spam ham detector or any kind of like text analytic task, so when we build a model, we try to feed that model into uh, input. Like that input of the model would be generally words, right? So in that case, our data set which is already present in the form of a sentence, now we don't want this as a sentence. So I cannot directly feed this entire sentence as a first input to the model. So what I'm trying to say is, like, we generally don't feed this entire sentence as an input. What we in turn do, we try to split this sentence into words again. So I am going to remove this sentence, or I am going to break this sentence into words again. So it is already available in the form of words, but you can clearly see this. It is in the other another list, and the another sentence is starting with the another list again. So what I am trying to do, I am going to merge all the list into a one single set, or a one single list. What I can say. So for that, what I am trying to do, I'm converting the list of sentences to a list of words. That is a list of tuples, only the words and a POS tag. So for that, what I'm going to do, I'm going to initialize a variable called tagged words. So this tagged words represents a comprehensive list. So what I'm trying to say, so I'm taking each and every sentence, and within the sentence, I'm taking each and every tuple, and from that tuple within this text corpus, I am going to put that tuple from that entire sentence into a single list. So this is what this step trying to do. So let's have a look on the operation, what I'm trying to say at the end of the day. So you can have a look on the tagged words. So you could clearly see that. So it is a list of list at the previous step. So now you could clearly see that it is a single list already. So it is a single list consisting of different words of from different sentences, and each element in the list represent a word, just a word along with the POS tag. So now we can clearly say that it is a list of tuples consisting of words and a POS tag. So we have 1,676 words or tuples in our final list. Uh, so we now have a list of about 1,676 tuples, that is word and a tag. Now let's have a exploratory data analysis on this data set. See, we have just overviewed about how our data set will be looking like, but we didn't understand the relationship. What are the hidden features? Like, what are these tags? Like, why this word is actually tagged with this POS tag? So we don't actually understand, or we have not understood what the data set is about. So that's why we conduct this exploratory data analysis in the very next step to understand the different nuances of the data set and we try to understand the various